This is a video on projectiles for physics students. So I have a cannon here. I'm going to fire a ball or a particle up, and what we'll see is the particle will stop at the maximum height. That's the first bit of information. Ball stops and then falls back down. Second bit of information. On the way up, the ball is decelerating, so A is equal to minus 9.8. On the way down, ball is accelerating on the way down, so A is equal to plus 9.8. Okay, just to show you that at a little bit of an angle. Now again, we're just dealing with vertical motion right now. Fired up, stops, accelerates on the way down. Okay, example 1. Example 2. If the cannon or ball that's projected upwards is at a particular height, and I fire it, remember it decelerates on the way up, stops, and then accelerates on the way down. And the thing to remember here is the velocity at that point on the way up will be the same as the velocity at that point on the way down, but we'll have an opposite sign. So this one will have a velocity up, that one will have a velocity down. And if the initial speed was 15 there, the speed will be 15 there as well. So we go from a speed of 15 to 0, from 0 to 15, and then beyond that, we'll go to a speed greater than 15. Now, if you were looking for the time of flight, that's the time taken for the particle to go up to there and all the way down. There are two ways to do it. The longer way is to say, okay, let's have a look at the journey on the way up, find the time taken to reach the maximum height. With that, acceleration is minus 9.8 and the velocity is equal to 0. And then what you do is you look at the downward section of the motion. So we'd have the initial velocity as 0 up at the top there at the maximum height, and then it would fall down whatever distance that is. You may have to calculate the distance to get to there, and you might have to then, work out the other distance then as well. All right, there's an easy way of doing it though, and that is you can say that when it's projected, its displacement is going to be minus the 6 there, look, or minus 100. So the displacement goes from there just downwards. So if you use that, and then the initial conditions, which are the initial velocity or speed, which is 15, and the acceleration at the point of projection, which is minus 9.8, the question works out much, much quicker for you. So let's have a look at a few physics examples based on that. All right, question 6 from 7.5. Stone is projected vertically upwards. It's got a particular speed. We don't know it. It reaches a height of 100 meters in 2 seconds. Find its initial velocity. Okay, second, greatest height reached. And then we have a time thing going on. All right, so let's look at the first one. What is its initial velocity? Well, if we look at it, we have the displacement, we have the time, we have it's projected up, so A is minus 9.8. So if we have displacement, time, acceleration, and we're looking for u, we'll use s is ut plus a half rt squared. For the second one, the greatest height reach, we know it stops at the greatest height reach. So we have the u from the previous part, and we're going to let v equal 0. Also, the acceleration will be minus 9.8. And the second part will not rely on the first part. So let's start with the first part. Like I said, we're given those quantities. That means we're going to use s is ut plus a half rt squared, sub them in, and we get initial velocity of 59.8. For the maximum height, again, part 2 is not related to part 1. So the times will be different, and so will the height. So let's have a look. Initial velocity is that. We know it stops at the maximum height, and we know the acceleration is minus 9.8. We're looking for s. So v squared is u squared plus 2as, and you get s is equal to 182.45. And you'll see again that they're definitely not related, part 1 and part 2. So what happens is the particle is fired up from a particular height. It reaches a height of 100. It continues onwards, reaches a height of 182.45, falls back down, reaches a height of 100 again, and then hits the ground. And part 3 is looking for the time taken to go from 100 meters to the next 100 meters. So what we have is the initial velocity, the acceleration, and the displacement. And I'm going to calculate the time in that case. So with those values, you'd use s is ut plus a half rt squared, plug it in, and you get two values for t by solving the quadratic. That's 10.204, or t is equal to 2. And we were given the t is equal to 2 in the first part. Now we're looking for the time difference, so subtract 2. Okay, second example. From a point 16 meters above the ground, a ball is thrown vertically upwards with an initial velocity of 24 meters per second. This is like the second example that I gave you in the animation or computer applet a moment ago. Find the greatest height it reaches, so that's when it stops, v is equal to 0, the total time taken to reach the ground, and the velocity that it strikes the ground with. Okay, so greatest height. We have the initial velocity, it's fired upwards, acceleration is minus 9.8, final velocity is 0, and we're looking for s. So that should be straightforward. The s value works out at 29.39 meters, but we're looking for the height above the ground. And if the particle was initially 16 meters above the ground, we have to add that on to give me a total of 45.39 meters. Now, the second part, the time taken for it to hit the ground. So what we do is we find the time taken to reach the maximum height. So initial velocity 24, a is minus 9.8, v is equal to 0. T works out as 2.5 seconds approximately. Now we want to add that time onto the time taken for it to fall from the maximum height down to the ground. And we know that height is 45.39 from part 1. So u is 0 because we're looking at the second part of the motion. The acceleration is 9.8 because we're looking at the second part of the motion. Total height, we had that, and we calculate t2. That works out around 3 seconds. So the time taken to go up and the time taken to go down, we add those together and get about 5.5 seconds. That's the long way. I did suggest there was a second way of doing it, and that was to say that the s is minus 16 because displacement is the straight line distance. We're not worried about the total path. And put in the initial velocity and the acceleration at the start as well. So u is 24, a is minus 9.8, and we say it's travelling a displacement of minus 16. So you get two time values. The only positive one is 5.5 seconds, which is your answer, and job done. And then the last part, find the greatest height to the ground. I'll leave you sort that out yourself.